if I give you just the fair value, or if I give you, for example, the internal rate of return of the product, that in other words is the first moment of the implied probability distribution at the expiry date, nothing more than that, what you get. And to stress the point that in my opinion you don't get too much, I make an hypothesis. I say that these four products are perfectly designed in order to have the same fair value at time zero. So in other words, you don't have the first line of this slide where there are the pictures, but you just have the fair value. How much information about the risk return profile of the product the price is able to convey? Very low. And the internal rate of return could be also misleading. Because, you know, if the probability distribution is quite regular, symmetric, unimodal, like in the case of the low-risk bond, the internal rate of return of this product is able to give you some information. But the more the distribution is irregular, the more the information that is displayed by this first moment is definitely insufficient in order to give you an idea about the risk of this product. To show you this, I make a further exercise. Since we know that when we have a probability distribution, we can approximate this probability distribution through a number of moments, through a proper number of moments, I just want to show you how much information we are losing if we just are happy with using the first moment in terms of information that we want to use to take an informed decision. In fact, by recalling some standard results of probability theory, we know that with a proper number of moments we can find a support region that comprises the relevant probability mass, and we can also approximate the value of this mass. In particular, we use the Christoffel polynomials, that are polynomials function of moments of the probability density function. Then we define the Christoffel function, and we know that with this tool we can identify a proper interval that approximate the integral of the density function, and hence the value of the cumulative density function, as you can see in this picture, for example, for k equal to 6, that is the number of moments that are involved, that are used for this exercise. And obviously we can also find the relevant probability mass that we are able to approximate by using this approach. And to compute the approximation of the probability density function that corresponds to a proper number of moments that we have defined, we use some asymptotic result of Totic and an approximation offered by Gerviadis Athanasoulis in 2009. Obviously there are some numerical tricks here to avoid some points of singularity, but this is a pure numerical problem. This is the final result. For our defaultable bond, we need something like 20 moments, so k equal to 10, in order to get, let's say, an approximation, a good approximation of this probability density function. And here you have some statistics. For the VPPI, we need 16 moments. Here we are, let's say, helped by the fact that we have just one mode in the distribution. It's full of kurtosis, but there is just one mode. And here you have the statistics that are behind that approximation. And for this very regular distribution, product in terms of distribution, we need 24 moments to have at least the capability of the system to approximate all this multimodality and irregularity in the shape of the distribution. What I want to say is that the more irregular is the distribution, the more moment you need in order to get some approximation. And now the question that arises is, how can I work with just one moment to take a decision or to understand what we are talking about here? In other words, the picture becomes a little bit more complex, and we cannot rely just on averages, just on the first moment internal rate of return to take our decision. And what we have to do? We definitely have to try to extract some information from the probability density function in order to increase the level of awareness about risk that characterized the product that we are talking about. And in order to disclose the design of the product towards the investor. This kind of information has to be supplemented, this additional information, in order to be understandable, first point. And secondarily, obviously, but actually this point is definitely more important than the other, should be able to capture all these features of the statistical properties of the product. Otherwise, we don't reach the goal of this, let's call it, exercise of transparency. Let's see a first alternative to do this. We just offer and communicate the probability density function. This definitely is the more, let's say, reasonable solution, and also the more intuitive. But unfortunately, this solution has a couple of pitfalls, actually not really, not immediately solvable. The first one is not written here, and so I told you in advance, is the fact that I don't believe that my mother, that used to teach philosophy, is able to understand autonomously the probability density function of the product. Maybe that, okay, I can help her, but we cannot expect that any mother has a son that understands something about statistics in order to give this kind of explanation. So, definitely it is intuitive to solve the problem just by giving the implied probability distribution of the product, but I don't believe that that could be the solution. Then we have also a second problem that technically speaking is also more interesting. The fact that the shape is model independent. And just to show you some results, if we compare the same product in terms of implied probability distribution displayed with the two different models, you see that the shape is different. As well as for the VPPI product, where we have used the Eston and the normal inverse Gaussian model. So two models that are definitely more different, calibrated on market data, but they display different picture. And the same thing happened for this index-linked certificate. We can say that this alternative is a complete failure. This alternative does not reach our requisites in order to offer some, let's say, insights about the risk-return profile of this product. But, in my opinion, there is a second alternative, and this second alternative is to offer a proper partition of the probability density function, of the implied probability distribution. In other words, if we put ourselves in the point of view of the investor, I don't care about the quantiles. I do care about I can lose, I can win, to be rude, and how much I can lose and how much I can win. It's not forecast, it's just what is implied in the fair pricing evaluation. Also because for forecast we have to ask somebody upstairs to help us. But definitely that is a piece of information that is implied in the computation of the price and that opens some more info with respect to just the first moment of the product. Yes, but I mean, by working on this intuition, maybe that we can add some more information and we can work with a different partition. And instead of just offering a partition something like you win, you lose, or we can use another partition, you win, you lose, you get back your money, for example. This is another. Yes, intuitively it works. In concrete, let's say, way, I don't think that there is an event that just have one figure, you know? You get back your money, it means that you invest 100, you get back 100. I don't know if you can compute probability just for this event, apart from some specific product that has some structure that guarantees exactly, you know, the final value of your investment. And so you have some concentration of probability mass on that specific event. So what we do is a superimposition of the probability density function with the risk neutral density. And just say, we create 4 events. The performance is negative, the performance is positive but lower than the risk-free asset, is in line with the risk-free asset, and is above the risk-free asset. And obviously, we compute what is called here the mean values, the conditional expectation that refers to those 4 events. Let's examine this alternative. One good point, one benefit of this solution is that this reduction in granularity actually involves only a very limited loss of information. Because if you put yourself in the perspective of a final investor, you receive 8 figures that gives you more or less the insight of what is going on with this product. With some also reasoning that, in my opinion, are closer to the normal, to the average investor. I mean, we are used to work also with interest rate, with return. But if I tell you, you have 30% probability that you invest 100 and you get back 50, with rude figures, definitely you understand immediately what we are talking about. This is the final picture for these 4 products. And without having the capability of reading the probability density function, you definitely have some information about what is happening in these products. And specifically, you can, according to your risk attitude, choose the products that fit better your risk appetite. Because obviously there is not, I mean, in a situation like this, okay, there are some products that are, I mean, so bad designed that there is a, if I ask the question, everybody raises the hand. I will never buy a product that gives you 80% probability of losing all your money, okay? But in other cases, you can have some different attitude, different risk attitude, and then you will take different decisions. Another advantage of this reduction in granularity is related to the fact that you neutralize the model risk. The intuition is behind the corner. If I don't examine, and then I will show you some statistics, if you don't examine the full distribution, but just 2, 3, 4 pieces of it, it is clear that what is a huge difference observed on one point becomes something manageable. And again, put yourself in the perspective of the final investor. Who cares about 1–2% difference in one of that event? Okay, the return is negative with a probability of 22%, or the return is negative with a probability of 23%. In terms of the picture, that is a difference. In terms of the, let's say, risk tolerance, perception, appetite, whatever, is not a difference. Or at least a relevant difference. Here you have the model used and parameters and the calibration outputs that has produced the tables and the final results. So this alternative has two main advantages. First, is easy to understand, can be understood by investors. And so you can fit your risk appetite. The second point, we are able to neutralize the different, the model risk. And in a certain sense, it allows to make a comparison also within products in an effective way. This is just one of the pillars that represents the three pillars approach for risk transparency that I have described in this book, that I do not recommend you to buy. I strongly recommend you to buy. The other two pillars are, one is synthetic risk indicator for the risk, and the other is by using some results of the optimal stopping time theory, try to compute what is the best time in which you can, what is the, let's say, the optimal time horizon for your investment.